I'm using this piece of example. It was used on the introduction of the trigonometry. A right angle triangle of three sides, that's a 90 degree across the 90, is a 345 triangle, where the angle sitting on the floor is 36. So we will play on the 36 degree to prove something. So if I take 36 as the theta, sine of 36 over h, we have done it before. If I use the calculator, 36.9 degrees is 0.6. We have done it before. If I take the cosine of 36.9 is the a over h, the ka, and that answer is also according to the SOHCAHTOA is 0.8. We have done it in the introductory trigonometry videos. Now, what about how can we find? We have got all the answers on the left side. If we will be given three sides or two sides, but we have to find the missing angle. What if, suppose 36.9 is not given to us? We are given a 345 triangle and you have to find the missing angle, which is theta. What we do, instead of left side is just for the backup, right side we don't know the angle theta. So we write sine theta as sine is the slope, is the opposite over the hypotenuse, OH. So sine of the angle theta is value of O is 3 and the value of H is 5. This is a easy 0.6. 3 divided by 5 is 0.6. I'm not just doing that part in the calculator. We have done it before. Now, this is very important. How we isolate theta is the last property on the basic trigonometry. To isolate the theta, we have a law for that. We just write the theta and the sine goes with the inverse value. Inverse is just a notation. And that notation, we can find this value by using the calculator. Some calculator will have the inverse notation the way I'm writing it. Some calculator writes it at arc sine, sine inverse, cos inverse, arc cosine, tan inverse, arc tan. They're same. It's just change of notation. So this is not dividing by algebraic law to isolate theta, is by the trigonometric law. So isolate the theta, write this sine equals on the right side, but write it as sine inverse. We can write the word inverse. We just write sine with this symbol, that's sine inverse of that value. So basically theta is the value of sine inverse of 0.60. I'm just repeating it because for the beginners it's something new. It's not sine to the power of -1, okay? It's sine inverse. Or this can also be taken as arc sine. Now let's use the calculator. We have sine, we have arc sine. Some calculator will have the sine inverse exactly with that sine with a -1 symbol as sine inverse. So we want to find arc sine, sine inverse of 0.60 or 0.60, same thing. And the answer will be 36.86. We have seen the answer 36.9. We know when we do trigonometry, there are some small changes and the difference of value in the decimals because those values are rounded up. We can easily take it as 36.86. We will just take it the value as 36.9. So we have seen the proof. To find the missing angle, we know the answer from the left side. We have done the angle missing on the right side. We take the inverse of sine of the value to get the angle value, and we use the calculator for that. Next example, we will like to find the same theta using cosine ratio. Cosine is the ka. So we have all the pictures on the left side. Ka is the a value, which is the 4. And so we will use the a value and the h value. So cos theta is a over h, which is 4 over 5. 4 over 5 is 0.9. Sorry, 4 over 5 is 0.8. Since I made a mistake, let's check it by the calculator. 4 over 5 is 0.8. Okay, done. Now we will do the same thing as we have done. Remember, we write the theta on the left side. Okay. And the law says write the theta, cos inverse of the decimal value, sine inverse of the decimal value equals cos with the inverse sign of the decimal value. And we don't use triangles, we just use calculators to do that. So we use the calculator. This calculator doesn't have the symbol cos inverse. So we will use arc cosine, which is the same as cos inverse of 0.80. And the answer ends up with 36.86. We just round it up to 36.9. So we know the answer from the beginning. Angle of theta was 36.9. It's on the left side. So this is how we find the missing angle. Using the other sides, using sine, cos, or tan, use the theta. When you are using sine, take the sine inverse. When you use cos, take the cos inverse. If I use tan, using 3/4, I can use the tan inverse. But theta will be the same answer. And we are done. One question, we have two missing angle, and if we understand it, we can find any missing angle on any right angle triangle using SOHCAHTOA. So we have to find angle A and angle B of a right angle triangle. The only angle given is 90 degree over here. And we have only given two sides. So how to work with SOHCAHTOA depends on which angle we decide to find first. That's the decision. That decision will make us choose. So obviously, by alphabetical order, if we decide, let's find the angle A. Now, when we decide angle A as our theta, that becomes the adjacent side, right? That becomes the opposite side, and that becomes the hypotenuse. Now, adjacent side is labeled with A. Let's write the A on this side, so it will be much more clear. That's the adjacent side, and that's the hypotenuse. Now, when I have A and H, do I run for opposite side? Because if I have A and H, I'm done. I can use the ka to find the angle A. So angle A is the theta on this one. Adjacent side is A, opposite, we are not bothered. Hypotenuse is 32. And it's not given. We can use Pythagoras, we don't need it. So cosine of angle A is the adjacent over the hypotenuse using the ka law. And the value of the adjacent side is 20. And the value of the hypotenuse is 32. And we use the calculator. We divide the 20 divided by 32 as 0.625. So we get the value of 0.625. Now we write cosine of angle A, cos of angle A is a decimal value of 0.625. And we have learned it previously. Isolate the angle, the previous video we have learned it. And it should be the cosine inverse of the decimal value. So it's cos inverse. We don't write inverse, we just write it as a symbol with a negative power. Sorry, I should not call it a power. It's just the notation of cos inverse of the decimal value. And we find that value by the calculator. So cosine inverse is arc cos, and the value we are looking for is, I have to cancel that value, is the arc cos. The value we are looking for is 0.625, and the calculator is giving us 51.3178. We just round it to 51.32 degree. That's the answer for angle A. Now we run for angle B. Now I just clean this part. When we are running for angle B, we are here. Now we need a adjacent side, but adjacent side is not given, but we are given the opposite side, which is called side O, and hypotenuse is with us. So we need OH. OH, go to SOHCAHTOA. OH is related with SO. So we will use the sine of the angle B to find opposite over hypotenuse. The value of the opposite is 20. The value of the hypotenuse is 32. Don't get confused. When we worked with the cosine, adjacent was 20, right? And hypotenuse was 32. That's with ratio to angle A. With ratio to angle B, opposite is 20. Doesn't matter, because they switch. So it's the opposite, which is 20 and 32, and we know the decimal value of 20 over 32 from the left side is 0.625. So sine of the angle B is 0.625. And we know right the angle B, see the left side, is cosine of the decimal value. So it should be angle B is sine inverse of the decimal value. Sine inverse of 0.625. We use the calculator. Sine inverse is not here. Some calculator has it. Some calculator will have arc sine of 0.625, and the answer is 38.62. Sorry, 38.68. Sorry about that. 682. We can take it 38.7, or I can just write it 38.62 the way I've seen it. So angle B is 38.68 degrees, and angle A is 51.32 degrees. If we add 51.32, add 38.62, and add the 90 degree, sum of the interior angle 180 should be satisfied. Just for the final satisfaction, we would like to add this angle, and add the 90 degree, just to check whether do we get 180 as sum of the interior angles. So we add the angle A, which is 51.32, plus the angle B, which is 38.68. Even if we don't get 180, we will get very, very close to 180, and the 90. Okay, we are getting 180. Sum of three interior angle of any triangle is 180.